welcome back on our second session. I'm here with Henri. He's from Copado company. For maybe some of you don't know what Copado company is. Before they applied as a partner to our conference with the old name Quentinel. Now they're joined other companies, so that's why the name has changed. And that's all for me. All from me for now. I will leave this completely to Henri. So enjoy his presentation and have a beer.
I'll also have a beer. I just got one just for this. Hopefully it's good. We'll see. Here we go. Oh, I think we can do the talk now. It could be. Okay, thanks Matthias for the introduction. And as said, we used to be called Quentinel as a company, and I work as the Chief R&D Evangelist from Quentinel or from Copado. I still sometimes say Quentinel because it's so new for us as well. We've only been in Copado for 3 months now, I think. And a lot of stuff has happened. So when I sometimes refer to the old name, it just comes naturally for sometimes. I had an idea of talk a little bit about what we do and go through a couple of themes or like the ideas behind why we do what we do. And then, of course, have a little bit of an advertisement in the end of our product or what we do with it and talk through that. So I think I'll start sharing our presentation. Here we go. I think you can all see it, hopefully.
Yeah, we can see the presentation.
Okay. Hey, thanks. And what I'm going to talk to you about today is a little bit about Copado Robotic Testing and what it is and what we are talking about and what are the kind of ideas behind it. As I said, we used to be a company, or we still are, a group of technology guys from Finland. And we've been developing a platform based on Robot Framework on top of that. And we were acquired by Copado a couple of months ago. So now we are part of this big US company. When we used to be a little bit smaller company with only 20 people, we now have, I think, 600 people, and it's growing really fast. We just became, Copado just became unicorn status, so 1.2 billion in valuation. So super big growth going on and a lot of stuff happening. So quite interesting to work with testing now on such a company and doing a lot of stuff on that side. So what I was referring to is this, that we used to be a company called Quentinel doing robotic software testing. So we do testing based on Robot Framework, and also we do RPA on top of that. And I guess many of you people have heard about Robot Framework. Robot Framework is an open source tool and testing tool that's been now going around and growing all over the Europe as well. And you can go ahead and Google it. It's a pretty nifty tool that was developed by Quentinel back in 2008 for Nokia. It used to be closed source for a little while, and then it was open sourced by Nokia, and now it's again back in the open source. And there is a Robot Framework Foundation, which maintains the core and funds development. And Pekka Clark, who's the original developer, he's basically doing full time with Robot Framework and developing it forward. And because of this, what we build on top of that is a kind of like an online platform on really using it. If you think about what Amazon did to Linux servers, that Linux server is kind of like Robot Framework, and we build an Amazon cloud infrastructure around Robot Framework. So what we do is we build a web platform that we offer as a SaaS service on top of Robot Framework and other different kind of open source tools that can be used in there. And now we are part of Copado, which is kind of this DevOps company, doing a lot of stuff in the Salesforce area. Salesforce is also pretty new to me, but there's this interesting trend now of going into bigger platforms, and lots of bigger platforms are also tend to become coding platforms because they get so complex. And you have to test a lot of those changes as well. You're not really coding, you're configuring, but you're configuring mission critical stuff like, for example, Salesforce or SAP or these big systems which basically run your whole business. And you have to be really careful with those changes as well. And what we are also doing now is testing those kind of configuration changes with the tools that we do. A little bit of the agenda, I kind of alluded to that, is first just go through some ponderings. The previous speaker also had really good ideas on why do we even test, and kind of take that distance on what I'm actually doing. Am I just doing, like, as you said, unit tests or all that? Those are the tools that we use, but why do we use those tools is something that we're going to look at a little bit at first. Then we talk a little bit about low code, which is something that keeps popping up more and more all over the world. Now everybody's talking about these low code platforms, low code this, low code that. And lastly, we're going to talk a little bit about communication and standards, and all of this relates to testing in a way that we also do on there, and what do we do in there. But first, why do we even test? Well, this risk to digital transformation is kind of like Copado way of talking about it, but what we are really doing and thinking about is currently, if you don't test your software and you deploy it, you have really big risks on what you're actually putting into production. And what's kind of happening now, when you look at the software market and look at what's actually happening in there, is that a lot of software tools have developed, evolved, became faster and faster. You can release to production in like 2 seconds. You take a Docker container, you push it into production, you get the new versions in there, and kind of all those tools have developed this really fast workflow where you can do very efficient development and get those ideas that you have in your head quite quickly to deploy into the actual environment. But verifying that actually those kind of tools and those changes that you're doing in your system, that they are actually doing the right thing that you want them to do, is something that those tools have not evolved too much. So testing has become the number one bottleneck as well to actual software development now. Or it's not testing, it's verifying that we are doing the right thing and verifying that everything that we do actually works. So it's not just about building, as I said, those unit tests and those taking time, but it's really about thinking, what do we want to test and how does this system even work? And as we all know, we want to test as early as possible, and we want to put that whole testing cycle into the coding cycle and deployment cycle as early as possible. If we deploy all of the stuff into production, it becomes more and more costly to repair those defects. And well, you know, when you find, of course, always you find some old defects and fix those. Those are easy fixes, but they might have caused a lot of problems in your system. For example, if we crash Amazon or something like that, half the internet will basically go down. So you don't want to get those kind of bugs into the system, and you really want to do that testing as early as possible and doing it in the coding, unit test, functional test phases. We ourselves focus mostly on the functional testing side, as we do a lot of UI testing and a lot of that's why the name is robotic testing, because we do a lot of RPA-like stuff in testing, and our platform can also be used to do that kind of tests. And the second thing, of course, is that the way you can do all of this testing, you can do it manually or you can automate it. And of course, we being an automation provider, we are kind of talking a lot about this, that you really want to put effort into automating all of those phases that you typically manually test, because then you don't have to think about it anymore. You do all the regression test suits, you do all of that, you make them once, use them as many times as you want to. And that kind of idea of thinking about it one time, automating it, is kind of in the core of whole software. And so what we are doing is doing it once and then automating, and kind of what you're doing at that point is instilling the culture that you actually have in your company into that automation. If something that you do is kind of like automated, you want to test automatically, you want to check some older bugs automatically, you want to deploy automatically, what you're basically doing is freeing up a lot of thought and freeing up a lot of time for people to actually do also something more and kind of help you develop your company even more, because you have the trust that all of those boring stuff like going through all the regression suits and all of that is automated, and you're going to save a lot of money as well and a lot of time, because, well, people don't want to do that much manual testing because you'll burn them out if you every single day have to do the same cycle of testing some feature. You want to offload that to AI systems or computers. That's what computers are good at, repetitive tasks done daily or monthly or even by the hour. But humans are not too good at that. We are good at also finding, discovering, digging through, using our brains in a kind of well, artistic is, I think, the wrong word, but I think you get the idea that I'm going through here, is that creative side of us. We leave more time to the creative side, but we automate the boring things. And that's like one of the ways that we want to do testing, is that we want to verify that we're doing the right things. We want to make that verification automatic, so we don't have to spend brain cycles on it. So that happens automatically, and then we can focus on doing all the other things as well. And one aspect that's been talked a lot now and in a lot of different circles is low code, or why nobody wants to code anymore. Everybody wants to do low code or configuration or something like that. But what are we actually talking about when we are talking about low code? I just like checking Google Trends on how this this is actually finished, but I think you can see the trend going upwards, that people are looking for this low code more and more, and it's a growing phenomenon. And during the times, everybody's kind of getting them more interested in it, because everybody wants to code. Everybody wants to create something new and to build that. But then you don't want to do hardcore coding. But actually, at that point, isn't it still coding if you do it on a higher level? If you think about it, nowadays when you talk about coding, you typically talk about JavaScript or something like that, or Java or C. But actually, all of those are still high-level languages. And kind of looking at that, what we're talking about here is code abstraction levels. And how we want to do testing is, of course, we don't want to actually build hardware to do the testing or write our test cases in assembly. You don't really want to do that. It's going to be tedious and difficult. Of course, in the lower level, if you do something like that, you have to do some unit tests with the technology that you're actually using to build your product and test that, and then trust the lower levels of abstraction to work. Kind of the same way that we don't test the actual Java language compiler, for example. We trust that that works. We only test the Java application that we're doing. And in the same way, this low code way of building is built on top of other bricks, and it helps you raise the abstraction level of what you're thinking. But I think it's still coding. It's still the same thing as coding, but it's just raising the abstraction level even more, so we don't have to build physical hardware in there, and we can do it on a much higher level. And I think even after low code, we are going to have something much more interesting now coming out with AI technologies and other kind of interpretive ways of coding. For example, I think my favorite, what I've been talking about in a lot of forums, is my favorite programming language would be that I go into a meeting room, I sit down, and I start talking to, okay, the application should be like this. I want a screen like this. I don't know, behind there it should do like this. I want the architecture to be composed of these three different parts. Kind of like you're actually explaining what you want to do to a production team or coders. In the same way, I think in the future, well, maybe not in 10 years, but like 50 years, you could just explain what you want your application to do to an AI interpreter and code it, basically. But let the higher levels help you in there, and you can only focus on the creative side of it and no repetitive tasks underneath there. And that, I think, is also core in testing, that you get much more efficient when you don't have to handle pointers. You don't have to handle machine learning or something like that. When you're writing those tests, you can focus on the human interaction, what the human does with the application, does that function. And that's why I think these kind of platforms, where it's quite easy to write high abstraction level code when needed, will be really good in the future. But those platforms also have to have the ability to deep dive when needed. You don't want to restrict that, but you want to offer a more effective, higher abstraction way of doing stuff. And that's what we've been doing a lot with the robot framework first, and then now with our own machine vision and AI supported tools for testing. The second thing I want to talk about that kind of relates to the first one is communicability and standards. Sounds boring, but I think it's not. It's more about, when you think about what we were referencing on this, it's really difficult to read, for example, I think many of you have, for example, seen screenshots of processor architecture or something like that. No idea what it does. If you just look at the picture, you have no idea what it does. And the same with the assembly. Maybe some of you can read it easily. I cannot read it. I haven't used it actively. Basically, I wouldn't be able to read what's going on in there. But if you then raise the abstraction level to Python, then I'd start having easier time to figure out what's going on. And if you can even then raise the abstraction level higher, like slow code or human-like interaction that we can push button this to do this in the application, it helps with communicability. And that refers to communicability and standards in a company. when you're not just you doing the business, you just like a one-man business, then of course you don't have to explain your stuff to anybody else. You can only do whatever you want, basically. But then when you start building up a bigger company and scaling up everything, then communicability and standards become more and more difficult. And like when you have multiple teams, every single one of those teams might take their own tools into use, do whatever they want. Initially, you might have some kind of standards on what to do, but slowly, as things seem to happen, people diverge on those. You might have some common tools, but no common procedure, for example. And that's not what you want to happen in a company, because then you have multiple teams that cannot talk to each other and you will not have standards. And that's what I kind of refer in a second thing. Oh, I'm missing the title from here, but it's kind of like the test automation, the path to test automation, nirvana, or whatever you want to see, the stairway to heaven. At first, when you think about a company, you have the hero tester come in, you have a problem, your product doesn't work, you identify that the problem is in the process, you do a lot of stuff, you need somebody to start checking the releases, that are they actually functioning or not. You hire a hero tester, that guy can do everything. He tests your application after each release, and everything kind of works out and everything's kind of good from there. And then your company succeeds, you start growing, you hire more people, you have a team of testers. And then there starts to be problems because everybody's testing in their own way. What you want is standardized ways of testing. So everybody's doing the testing in the same way. You have, for example, test scripts, like manual scripts, like in a theater, that everybody can read, everybody can share, speak the same language, and easily compare notes. You want to have standardized ways of testing and do that. Again, by following this kind of steps forward, you can again grow, your company can grow. And then what starts happening is that you are starting to use a lot of cycles and a lot of time on doing manual testing. You kind of come full circle, and you start talking, what about automation? Can we automate these boring parts in there? And maybe somebody from the team is like a good wizard on using robot framework or some other tools, and starts building test automation in there. And again, solves the problem that, hey, we can actually do a lot of these repetitive tasks using some tools, open source tools, Selenium, robot framework, and a lot of these other tools. And again, you can progress. But after that, you start running into problems. Like you have multiple teams doing the testing and running automation. You have a lot of resources both into the actual automation infrastructure and teams and people. And typically at this point, you start to run into problems with open source tools that you cannot really easily scale them up to the level that you want. You have to buy computers to your own lab. You have to buy some servers to your guys and all of that. And that starts becoming a hassle of its own. You need that guy to run all of that, run maintenance and all of that. And it starts becoming a problem. And how you can kind of jump to these stages, or this is the stage that typically big companies are when we talk to them. What you want on top of this is basically having a common platform and ways of automation, which are easily communicatable between teams. You can easily explain to the other guys what's actually going on with our product, what's actually going on with the test scripts, and everything running on a common platform. So it's easy to talk to not just the testers, but managers and everybody else, and kind of help that communication out so we can really go back to the root of the problem. That, are we doing the right thing? Is our stuff good enough? And do I actually have the confidence to press the release button? And that's something that Copado is branding a lot on. We want to make release dates obsolete, that you don't have to be scared on release dates. You can do those no stress deployments. You can deploy it and not be scared on what's going to happen. And this is the kind of philosophical side of what I've been thinking a lot about testing and why we are building this kind of cloud platform and why we do what we do. Of course, there's a little bit of advertising for our product as well, but kind of background on there. And that's where Copado Robotic Testing, or if you've heard of Sentinel Pace, comes in. And what we do with this tool is, as we said, we want to solve the kind of testing problems that always comes here. You want to have speed. We want you to be able to deploy stuff very fast with very good quality and easy to test, and staying in budget and sign cost. So you don't screw up your test pipeline or your product pipeline with that, and kind of help with this holy trinity of stuff that I want the product faster with more quality and cheaper, which typically doesn't exist. But yeah, we work on any platform. We are not, as I said, Copado is a Salesforce company, and we do a lot of stuff with Salesforce, but Sentinel was platform agnostic. We can do any mobile device. We can run our testing platform on top of Android. We can run it on top of iPhones. We can run it on SAP, any kind of cloud application, any browser. Oracle, or even any on-premise app. If you have like something that needs to be in a bunker and not touch the internet, we can also help you with those tools. And as I've said, what we want to do with this is we want to help you build more and better test cases with easier to use interfaces, easier to describe to people, and how we're actually doing that behind the scenes. We can interface with any kind of IoT or hardware in there. We offer super scalable infrastructure, basically, because we are built on the cloud. You don't have to buy testing machines. You can immediately set them up. We've built a lot of AI to help you guys analyze your test reports, find problems, fix problems even faster, and write better test cases. I'm going to show you a little bit of a demo, then a sneak peek from there. And of course, if you come to the SANAE conference, we can run you through basically anything. We can even test your web page in there, and come check us out on the booth. Then you can test from anywhere as it's in the cloud. This is something that seems to happen now a lot. As previously, a lot of these older generation tools were desktop tools, like 360 is offering those. A lot of different kind of companies are offering tools that you had to install to a laptop. But because this is in the cloud, you can stay at home, you can go to vacation. Well, I don't want you guys working from vacation, but anyway, you could fix something critical from vacation because everything is accessible from the cloud. And actually, I even dare say that cloud is more secure by design, because the evolutionary nature of the being open to internet forces you to be secure. If you leave a database open or something like that, you're going to lose everything and you're going to lose your business. So that cannot happen. So that will be evolved out of the systems in the same way that if you have a server inside of your company, maybe what happens is maybe you don't put the most difficult password in it. Maybe it's test 1, 2, 3, because well, it's not connected to the internet anyway, except when the internet puts it into the internet, and bad things happen. And the same idea is that we want to offer a secure environment for cloud where you can run as many tests as you want on any platform as you want, with low-code testing and self-healing, and integrating with all of these great open source tools on Robot Framework that we've done previously. So we don't lock you into just, recording or something like that we want, helping get all of it out of it. And just some numbers, we have some big customers as well using this. I think the Finnish Tax Administration is the most interesting one, as it's the Finnish Tax Administration, so it's a government thing. Tax has to work. There's a lot of integrations, a lot of tests daily. And all of these kind of other companies are just showing that. They're Finnish references, but Finnish biggest telecom carrier, industrial equipment, we can test a lot of stuff with this and in the cloud. And there's also a demo on YouTube, but I'm just going to offer you a short sneak peek on what you can do. Actually, what you can also do is, I'll just close from here. Oh, not that one. Developed, and kind of want you guys to see that we can run and create test environments really fast with it. So I'm just going to use the Salesforce end-to-end demo project to just quickly show you guys what I'm talking about. What we refer to robots is basically execution environments, and you can get some stats out of this. I can very quickly spin up a new environment. I'll just call it SANAE test env, and a really nice description in here. And we can choose where do I want to run it. I can run it in the cloud, or I can run it what's called a static mode. So this is if you want to install it on a local machine, for example, but you want to get reporting to the cloud, you can do that. But I'm going to use cloud in here. And we can also use a web robot, or we can do mobile. Sorry about that. We can do mobile with our partners Bitbar browser stack. So you can test Android phones actually on Metal. They have like racks of phones in there. So it's actual phones that you can do there. But we're just going to use web for this testing. So typically what would happen at this point is, if you want to do the same kind of thing, you'd have to order a computer, start installing kind of operating systems, installing all the test tools that you want. But we can just quickly spin up a cloud environment, and there it is. It's already done. And what we can immediately go into starting to build a test suite for it. And we support kind of any of the jets, Bitbuckets, GitLabs, all of these natively to the APIs, but we can also interact with any JIT that you want just through the Git commands and the way that Git is built. So version control is also baked in. And if you don't have your own, we also host our own. It actually still says Sentinel. I have to file a bug report for that. So we have a lot of the old references still in the application. I'm just going to quickly go build a starter suite. The starter suite is a demo suite, basically showing you what can be done with the editor. And now we have a test suite. And what you can do with test runs. You can stream them if you want to see what's actually going on. You can record videos, and you have regression development history that will show up in here. But what I want to do is I'm just going to show you the actually test scripts and the idea that we've been talking about this high-level concepts or easy to understand tests that you can even share with your manager and they can understand what's going on. And here it is. I'm just going to show you what we are testing. We have this. Come on. Work for me. Here we go. We have this nice little demo web shop available. Just test whatever we want to and test our test scripts on it. So looking at this kind of test format that we have in here, it's really simple keywords. And you don't see any expats in here. You don't see any HTML. You don't see anything like that because this is designed to work on many different browsers that you want to and kind of quite easily understand what's going on. Is go to this website, click text hash of the year, verify text. That's the slim fed 100% color shirt exists on the desktop. Add it to the cart. Verify that the text is there. Verify that it has a data text and click text continue shopping. So quite concise and nice, easy to understand keywords. And what we can also do is run what we call live testing. And this is kind of a hybrid of actually running the test live and also kind of recording. You can see that this is a full-blown developer environment, but if you don't like this, you can also use VS Code paste editor to do this, all of the same stuff. But kind of what we can do from the cloud is we can run these tests on this browser that's on now inside. You could pop this out as its own screen, but because of the screen sharing that I'm doing, I'm just going to keep it in here. And we can fully interact with this. We can click all the stuff in here, navigate with this browser, and we can even, if we have problems, we can inspect elements in here. We have all the features that you want to. But what's kind of interesting is, as I said, I can run this test, for example, here. It's going to run the test. It's going to verify it. You get the logs. But what's interesting is I can hit record. I can go to SANAE there. And it's going to actually create the keywords for me on the execution trace on the bottom left. And then I can go into buy tickets, scroll down. I remember there was a form in here. Oh, let's see what else we can do. We can go in here. We can check this out. We can navigate anywhere else. It's going to constantly build this kind of keyword trace in here, like telling you the simplest way of doing that. Like click text buy tickets, click text COVID-19. Those are like the most easiest way to get into those. You don't have to do any kind of expats or anything. This is all done by machine vision, and we can show you a lot of this as well. But this is actually also free. There's a free trial of this. You can go to our website, canada.com, and start testing for free. There is a personal. Now it's going to log me in because, well, I'm logged in. Yeah, you would need to log out if you wish to create a new account. But you can go and test it out. We have 60 minutes of permanent runtime for everything, and you can check it out if it's interesting. And I think I'm pretty much on time here now, I guess. So thank you for this opportunity to talk to you and demo some of this stuff and talk about what I think about is the interesting thing in test automation and what we should be probably focusing on test automation as well.
So thank you, Henri, for your presentation. I think it was very insightful, at least for me. And if you want or if you would like to join Henri at the Copado table in the lobby, after I end the session, he will be available there for all your questions or concerns about Copado robotic testing. So I think I hope you enjoyed the presentation, and I will end the session and see you in the lobby.
Thank you.
Cheers.
Thank you.